Hello and welcome. I'm Adrian Dickson from the Science Division in the New South Wales Department of Planning, Industry and Environment. The title of this presentation is Can Citizen Science Inform Science? Evaluating results of the Bellingen Riverwatch Citizen Science Program and a parallel government monitoring program. To begin, I'd like to acknowledge the Australian and Torres Strait Islander peoples of this nation and pay my respects to ancestors and elders past, present, and emerging. In the summer and autumn of 2015, the Bellingen River snapping turtle, Mayu Shelley's George's eye, suffered a mass mortality. Initially, the cause was unknown, but there was concern among the community that it was linked to river water quality. But scientific investigation has since shown it to be an epidemic disease, apparently caused by a previously unknown virus. This mortality event led to the Bellingen River turtle being listed as critically endangered, and a partnership with a range of stakeholders planned and implemented a captive breeding and recovery program. At the time, there was a small citizen science program underway looking at water quality, and the turtle deaths triggered Green, the organisation leading the citizen scientists, to contact government authorities. This led to community engagement meetings with staff from various teams within DPI, and discussions initiated the development of two parallel river monitoring programs, one being the Bellingen River Health Program, and the other, the Citizen Science Program, became the Bellingen Riverwatch. The DPI Science Bellingen River Health Program is delivered by staff qualified and experienced in developing and implementing river health monitoring programs. DPI Science follows methods, standards and protocols required for compliance with water quality monitoring programs and New South Wales Rivers sampling protocols for macroinvertebrate and riverine habitat assessment. Bellingen Riverwatch, the Community Citizen Science Program, grew from the community program that was led by Green and commenced with a few volunteers, but has since grown and now engages 40 local community volunteers and 5 schools. Riverwatch now collects data at 30 sites on a monthly basis. Results are thoroughly checked by a Riverwatch coordinator, and data is subject to QA/QC at several stages, including prior to the upload to the New South Wales Waterwatch database. In addition to water quality monitoring, other complementary citizen science activities have occurred, with more planned in the future. Riverwatch has connected many people with program and project partners and affiliates from local, state and federal government, zoos and animal care facilities, local primary and high schools, and private entities who provide sponsorship and in-kind support. Bellingen River is located on the mid-north coast of New South Wales, between Port Macquarie and Coffs Harbour, as shown on this map. Here's a list of sites and information on which sites are included in the two parallel programs. DPI Science uses a calibrated multi-parameter water quality meter for in-situ variables, and grab samples are collected for nutrients and sent for analysis at a NADA-accredited laboratory. With guidance and advice from program partners, Bellingen Riverwatch has developed its own manual defining the procedures for volunteers to conduct site assessments, take site photos, and test water samples. Riverwatch uses kits from New South Wales Waterwatch, which are a standardised set of equipment with procedures used by Waterwatch groups throughout New South Wales. This is a table of the water quality variables collected for each program. And this table provides information on the accuracy of the methods used, which is important when evaluating and comparing the quality and consistency of water quality results generated by the two parallel programs. So some results. Looking at the main water quality variables, here we see temperature. You can see that there's comparable results in the median values. And the Bellingen Riverwatch data has a greater range. And this is likely a reflection of the greater spatial and temporal coverage of the Bellingen Riverwatch program. Similarly, pH has comparable median values with a greater range in the Riverwatch program. Turbidity, we can see that Riverwatch has some very high values, and this is probably indicating a greater spatial coverage and temporal coverage, which takes into account some high flow periods. You can also see that the median values are reasonably similar, yet the median value of the Riverwatch data is limited to the accuracy of the method used. For electrical conductivity, we can see that the median values are very comparable. Again, the Riverwatch data has greater range, some higher values, likely reflecting the greater spatial and temporal coverage. For dissolved oxygen, we can see median values are similar, with, again, Riverwatch having a greater range and some low values, highlighting potential problem sites. Looking at the available phosphorus data, we can see the Riverwatch and Deep Ice Science median values are quite similar. Yet the Riverwatch data has some very high results, which requires further investigation. So let's take a look at dissolved oxygen. This is an important variable for the Riverwatch Citizen Science Program, as there were community members that perceived low DO values may have stressed the turtles, making them more susceptible to the virus. By looking at the frequency histograms of the two programs, we can see generally that they are comparable, with distributions that conform to conditions expected for natural waterways. Looking at the box plots of each of the sites, we can see that Riverwatch data has generally a lower median and greater range for most of the sites. There are a few outliers, but this is not uncommon for any data set. Considering patterns in the data at the site scale, there are some sites where median DO is very low. For example, site B7.1. This is a small intermittent creek in the Bellingen Township and is impacted by stormwater and exhibits conditions common to urban streams. Site S1 is Spigot's Creek and is heavily impacted by agricultural land use, and being a smaller tributary reduced flow consistency. We can see that these results show that Riverwatch data are in line with ecological theory of impacts to water quality. Looking at sites in the upper Bellingen River in the habitat of the river turtle, we can see that the Riverwatch program has consistent results. And with some smoothing of the data, we can see some seasonal patterns start to emerge that Deep Ice Science program cannot capture, that is limited to biennial sampling. This suggests the Riverwatch results are largely indicative of environmental conditions in the upper Bellingen River, which is important when considering the ongoing monitoring program and how the data may be used to inform management of the turtle population. Another water quality variable measured in both programs is phosphorus. This is a variable of concern to citizen scientists due to the links between agricultural practices and increasing phosphate concentration in rivers that can cause algal blooms. Looking at the frequency histogram, we can see that most results for both programs are within the guideline, and skewed to the lower values, as expected for waters that flow from well-forested catchments. Looking at the results for each of the sites, we can see that all sites have a median phosphorus within the guideline, except site B 2.1, which is a small tributary in the upper Bellingen River catchment. Knowledge of this site suggests that there may be a combination of naturally occurring and anthropogenic sources of phosphorus, coupled to a low flow system. But this would not have been detected or determined without results from the Riverwatch program. You can see most sites have outlines suggesting there may be some issues with the accuracy of the field method. However, it may also point to high temporal variability. If we dig deeper to investigate temporal trends in the phosphorus results, we can see that the Riverwatch program is able to pick up variability in the phosphorus data that the Deep Ice Science program would otherwise miss. Here's another example from a site monitored by some of the more experienced Riverwatch citizen scientists. So we can see that by comparing results of the two programs, we can see how Riverwatch is providing a more accurate picture of variability in environmental conditions in the waterway. To sum up the results, the Deep Ice Science Bellingen River Health Program provides highly accurate data in line with quality standards and required for comparison to national water quality guidelines. It provides data that gives a distinct snapshot of environmental condition. However, the biennial monitoring is somewhat deficient for understanding variability within the ecosystem that is required to detect change at a temporal scale required to inform management of local scale land use activities. The accuracy of the Riverwatch data is limited to the accuracy of the methods used, but it is important to note that Riverwatch is demonstrating that accuracy is not limited by knowledge of scientific methods, as the Riverwatch participants are generally well educated in the methods, with training and QA/QC provided through a well-coordinated program. Riverwatch shows citizen science can vastly increase the spatial and temporal coverage of a monitoring program, and at a greatly reduced cost, providing a better understanding of the patterns and trends in environmental condition, and providing a good alert system to unexpected or unfavorable changes in the river ecosystem. Riverwatch has also demonstrated improvements in accuracy over time, with the improvement in methods, QA/QC, and citizen scientist knowledge that will only get better over time if participation is maintained. So, can citizen science help to fill the gaps? I believe so. By fostering the connections between citizen science and the scientific community, Riverwatch continues to provide highly valuable data. It is setting the standard with a strong focus on quality and consistency, considerably enhancing data quantity in an otherwise data poor or underfunded area. This is a standard that other programs and river management authorities are closely observing, with lessons learned throughout the program being passed through the connected network of stakeholders, thereby improving current and future citizen science programs. While it has not been an easy or clear path, it remains a determined and well-coordinated community group. The program continues to grow, with more community members becoming interested and planned expansion into other areas, such as biological monitoring and riparian habitat restoration. In addition, funding from local land services and the biodiversity and conservation branch is facilitating ongoing support from Deep Ice Science. Riverwatch has helped to inform management decisions that are not only assisting the recovery of the critically endangered Bellingen river turtle, but also helping to maintain and improve the health of the Bellingen River and its tributaries. In addition, the program provides a platform to educate and cultivate knowledge of river and ecosystem health within the community. And this local knowledge will become increasingly critical to the management of river systems into the future. Riverwatch demonstrates the management of river health and the state of natural environments more generally should strongly consider integration of citizen science as both a critical tool for community education and a means for collection of highly valuable data that will help us understand, manage, preserve, and protect the natural environments that are critical to our survival and that of future generations. Thank you. Any questions?